Hello everyone, this is Professor Maloney, and today I'm creating a video recording as an overview for Chapter 7 or Unit 7. So Unit 7 introduces a little bit of information on enumerators, and enumerators are used when we want to create our own simple data types, okay? And then the first programming exercise in this chapter is going to have you use that example. And of course, I'm not going to give you the example today, but on Wednesday, my next video will be to demonstrate an example of using a simple data type. And basically, it's going to be to figure out the shape of a triangle. Is a triangle isosceles? Or is it equilateral? Or is it, what's the third one? Oh, come on now, guys. So think about that. And then I'll also have a no triangle option in there. Well, I will. I'm going to be giving you guys an example. And I'm going to also actually probably make that an example where I give you credit for a programming exercise, again, similar to what I've done now since, I guess, Chapter 5 anyway. For sure, I did it in Chapter 5 or Unit 5 and Unit 6. But anyway, so simple data types. A simple data type is when we create our own data type, okay? In Unit 7, if you've started reading it yet, they create 3 different examples. One is called an enum for colors. One is an enum for standing at college, like freshman, sophomore, junior, or senior. And one an enum for sports. And for sports, they did maybe basketball, football, hockey, baseball, soccer, and volleyball or something. But so an enum, and every enum would then need to have a data type depending obviously on what we're doing with it, okay? So for this overview, I'm going to kind of go through the PowerPoint a little bit more than I normally do so that you can kind of see it. It's sort of hard to envision what these enums are doing if I don't show you some actual, show you a little bit more on the PowerPoints than I normally do. All right, so let's go ahead and do it. I'm going to try to restrict this thing to about 30 minutes. We'll see. I'm not normally successful when I do that. I normally talk way more than I want. But I will be giving you an example program already in a couple days on Unit 7. All right, okay. So let me see here. I want to go to my COP 1334. Oops, I don't want that. I want this one is 2021. And oops, I don't want that either. Where am I? 2021 Homestead. And I want PowerPoint files. Okay, so Chapter 7. See, there's only one to go, okay, after this one. All right, now this particular chapter now is much shorter than most of the most of the chapters we've been doing lately. All right, it's literally 31 slides, so it's not too bad in terms of that. And obviously the next one is a big chapter. It's on arrays. So this is, and that ends the class. Arrays are huge. But for this one, I'm going to give you some good examples as opposed to just making you focus all your efforts on reading. I'm going to minimize this for now though, because I want to make sure that I am recording this. Sometimes I do mess up. Stop recording. Yes, I am recording and I'm sharing. I've got my speaker on. Hello, hello, hello. It should be on good. And let me make sure my blah, blah, it's on loud. Yes, it is. All right, so we're set. Now, where's my PowerPoint? PowerPoint. All right, so Chapter 7, user-defined simple data types, but also namespaces, and a little bit more on the string type. We keep coming back to the string type in this chapter, and every time I do it, I say that in this chapter, we're going to start a little bit more because you got to understand that, like, this word here, chapter, okay, that's a string, and that string data type has characters 0, 1, 2, 3, 4, 5, and 6. The length of the string, because we reviewed that a couple chapters ago, so it's 7, and the values of those numbers are from 0 through 6. So R is a 6, H is a 1, P is a 3, T is a 4, H is a 1, C is a 0, right? So, I mean, that's when we get to the point where we're talking about the strings again. But this time we're going to be doing a little bit more from the really almost the sense of an array, which is the next chapter, chapter 8. It'll at least show you how we're going to start coding things with arrays. All right. So, and creating our own namespace, really we don't need to do this. It's just not necessary for an introduction to C++ class, but I'm going to show you, and the PowerPoints will show you how you can create a namespace, your own namespace. And then just like you have a using statement, using namespace std, right? You can have a namespace and whatever the example they give us will be, and then you use that namespace so that you don't then need to do the : when you're referring to the variables in that particular namespace. But let's start with the simple data types, right? Okay, so you're going to learn how to create and manipulate your own simple data type called the enumeration type. Now, even though it's enumeration, the keyword and the reserved word for C++ is enum, E-N-U-M, all right? What will we do with these enums? Well, so sometimes, and I think I mentioned in an earlier chapter that if you think about certain things in terms of from the perspective of a business, okay? A lot of businesses have, they're hiring left and right, especially these days, so thank God for that. But when you're hiring new employees, you can probably figure out with relative ease that you're going to need a certain number of variables, and you can sort of create an enumerator on it, right? Like every employee, what's every employee going to have? I mean, for most companies, well, most employees will have an employee ID for sure, right? Most employees will have a required first name, a required last name, and probably an optional middle initial. Now, an employee ID might be a string, but it also might be a number. If it's a number, it might be a auto number, or it might be a number that somebody at the company assigns, or the database assigns at the company. All right. Telephone number or cell number, right? They're going to have an address 1, perhaps an address 2, because a lot of people live in apartments or townhomes, or something with a number associated with it in addition to the street address. So, and of course, a city, a state, a zip, and or if it's Canada, obviously the provinces and postal codes. But that kind of stuff. All right. So in this chapter, in chapter 7, the three big examples really on enums that they're going to be giving us, and they're going to go over the same ones from basically from slide to slide. They'll have one enum for colors. Okay, so you're going to see how we create enums, and this one would be colors. And when you create an enum, so it's enum, and then what you want to name it. All right, so in this case, again, enum space colors. Okay, and then space, and then your open and closing curly braces, and whatever values you want to put in that enumerator that you've created. All right, so for colors, I don't remember all the colors they want, but basically brown, blue, red, yellow, whatever. And then they're going to have another enum for standing, and this standing is going to be for like college students, a freshman, a sophomore, a junior, or a senior. So that would be creating an enumerator called enum, and then the name of that would be standing, open curly brace and closing curly brace, and in between those curly braces will be freshman, comma, sophomore, comma, junior, comma, senior. Okay, and you can see how obviously that would then lend itself to using things like for loops, right, to go through the enumerator. Meaning if we have a set of values that we're going to be using and we want to iterate through, let's say, 200 students to figure out how many are seniors, we're looking only for seniors, or we're looking only for freshmen or whatever, so that we can then do something for those students. Maybe they need to attend some kind of financial aid session, or perhaps they need to attend some kind of session about graduation. Perhaps they need to attend a session because they're going into computer programming or computer engineering or whatever. So using for loops with enum types also works. And obviously, therefore, we would also be inputting data, reading from text files, right, into the enum type as well, and outputting data. So it's like anything else we've done thus far. It's just that these are simple data types that we would be creating ourselves. All right. All right. We'd also, of course, we have the write function. So basically, it's unit 7, or again, chapter 7. So everything we've done through chapter 6 enters into this process. So I just talked about the for loops and how they can be used with enums. And of course, again, I'm going to be giving you guys demonstration videos as I always do, starting literally in the next class. So Wednesday of this week, you're going to be getting an example program. But anyway, so using functions as well. Functions came from chapter 6. Here we are in chapter 7, and we're going to be using loops from chapter 5, functions from chapter 6, and of course all the earlier stuff we did. Right? We're going to be using switch and if statement logic as well in this chapter dealing with our enums. Okay, and then there's a type of enum called anonymous. An anonymous enum means we're not naming it. So it would be enum and then an open curly brace and a closing curly brace with the values in between. Just means we're wanting these variables or these values, but we're only going to be using them here and then we'll just get rid of it. But using it in an enum makes life easier for whatever that particular program is going to be designed to do. All right. So those things will for sure happen all the time when you're dealing with anything in the programming world. We know that we have to deal with certain things, and those certain things, sometimes we say, well, do we actually need a variable for something or not? Maybe we don't, other than using it to capture the information input, but then we don't need to save it because we would have like a history database or something for things that we're going to be saving. All right. And then we're also going to be talking about type def. Okay, the type def statement is something that we also use with enums, and then we're going to be going on to namespaces. But you see, it's only a little bit, just a general introduction to namespaces. And finally, yet another, like part 3 really on strings, because we started with strings in about unit 3, came back to them in about unit, I don't know, 5 or 6, and then coming back to them again. Actually, probably chapter 4, yeah, and then 5 or 6, and then 7. So almost every chapter we're dealing with strings a little bit these days, okay? So now we're going to just go through and talk specifically. All right, so what is an enumeration type? So, and there's about 4 or 5 slides, obviously, on it. So a data type is a set of values with a set of operations on them, right? Any data type is a set of values with operations on them, whether it's a string, in which case those set of values would be, for the most part, string manipulation. Whether they're numbers, in which case most of the values upon operations on them would be dealing with multiplications, divisions, maybe modulus division, remainder division, you know, things like that. And then they also would have other things that we're going to do on them. But enumeration types are where we decide, you know what, maybe rather than just using the standard, a string data type, standard an integer, standard a double, standard any values we want, booleans if that's going to be the case, chars if that's going to be the case for character. But an enumeration type that we want to create for ourselves, we could then have multiple data types within it. So like if we were declaring a new employee, so that new employee enum might be called employee, or it might be called new employee. But whatever it was called, it would then need the characteristics, meaning in variables, that allow us to get all the information that we need and save it to whatever name, type def is the name that we have for that particular variable. All right. So enumeration type is a simple data type created by the programmer. It can have lots of different data types within it. It's just something we're creating. So how do you create one? Well, you need to have a name for the data type. You need to have a set of values for the data type. And you need to have a set of operations on the values, you know, what you're going to be doing with this enumeration. Okay. Oh, you know what? Sorry about that. We're on slide 5. Let me just function 5 this thing here. All right, 1, 2, 3, 4. All right. So slide 2 on this topic. You can specify the name and the values, but not the operations. So the syntax for the enumeration type is enum. So what does that mean? It means obviously enum is the keyword, the reserved word. So enum tells the compiler that we are creating our own data type. Then we have to have the type name. Again, in this chapter, they're going to be showing us colors, they're going to be showing us standing, and they're going to show us sports. At least those 3 enums over the next 10 or 12 slides, okay? And again, remember, there's only 31 slides. So in today's case, we're getting through this faster. All right, excuse me. Then the values. What are the values? Well, the values are the enumerators. That's the values or the identifiers for that particular enum. So when it's going to be colors, it's going to obviously have colors. When it's sports, it's going to have sports teams or sports names, you know, football, basketball, hockey kind of thing. When it's colors, it's whatever colors we're going to be using. When it is, what was the other one that they are using? Standing. It'll be freshman, sophomore, junior, or senior. Okay, so that's what the value 1, value 2, etc. are. It means they're all optional. You have to have a value, but you don't have to have 2. You don't have to have 22. It's what you're going to need to make this work. But remember, you normally want it for more than what the chapter is going to give us. Like I mentioned, employee name or new employee or employee, however we would want to call that, where we would have a value for emp ID, meaning employee ID, F name or first name, MI or middle initial, L name. And then what else do they have to have? A cell phone. They have to have an address. They have to have a maybe an emergency contact. So all the information that they might need would all be called that one enum. And then in your program, and by the way, you declare enums above int main. Okay, so it's similar to what we were doing last chapter with creating functions. We started with what? A function prototype, right? Then we had a function definition after int main, and we called the function within int main. Now, with these, we're creating our own data type. So like the variables or the data types, the enums are going to be declared where we would normally declare constants, meaning, again, above int main. All right. And once you have a name, let's just pretend this was employee. Okay. And then employee has all these values. So then with the dot notation that you can get with things like C++ or C# or Java, or the big languages these days, you can do emp name dot, you know, to pull up the values that are legitimate based upon what was declared in the enum. All right. All right. So the enumeration type is an ordered set of values, and you know enough now to know that anytime you have a certain number of values, the first value is always going to be 0. In the case of an enum, it's the default value. So it's always going to start at 0, and if there's only 1, obviously, then that is the default, but 0 is the default. Okay? If you have three values, it'll be 0, 1, and 2. A value used in one enum cannot be used by another enum in the same block. What this basically means is if you have, and they put an example in the book on this. I don't remember if it's in the slides or not. But if you have an enum where you're listing a bunch of, let's say, course names, and then you have another enum, maybe actually a variable on the first enum, then that one can't have any duplicate names from what's in the first. So when you're dealing with enums, you need to understand the structure that you're creating with them. It doesn't make sense, basically, what this statement, whenever we come to it, is going to mean. You don't want to have a variable on a block, any values in a enum block, and then have it set up where you're referring to a difference, because the block has the values. So therefore, only those values are good. You can't then change something into it, right? And that would apply to anything within a block. A block just means if you have your enum and then you have another enum within the same area, then it's, excuse me a second, my grudge is going, that's my son. I gotta ask him. I can't get out of here now. Sorry. Anyway, I know you've been hearing that a lot. I don't know what he's doing. So anyway, that is the enumeration type. Okay. And some examples, if we have an enum for colors, that the key thing to remember is that with enums, they are similar to everything we've been doing in class, other than having opening and closing curlies, which we obviously haven't been using too much yet. Okay. Once we do arrays, we're going to be dealing with them a lot more. But anyway, so enum tells us we're creating our own data type. In this case, the enum is color. So we're creating a data type called colors. And in this case, we're only allowing these 5 colors. So you couldn't have black, you couldn't have white, you couldn't have pink, you couldn't have orange. You know, it's only these values, okay? And the values belonging to colors are brown, blue, red, green, and yellow, all right? Then another one for standing, meaning standing in school. You're a freshman, or you're a sophomore, or you're a junior, or you're a senior. Now, even though these are, and I again apologize, I don't know what's going on, but my garage door is bothering me a little bit. It's one member of my family that's going in and out 10 times. I apologize. So the one I mentioned about employees, though, makes a little bit more sense in terms of how you're going to be using it. But either way, these are data types, and that means that for standing, you'd only be able to use freshman, sophomore, junior, or senior. For colors, you'd only be able to use brown, blue, red, green, or yellow. Oops. Okay, all right, that's that one. Now, here, they're going to show some things talking about, well, look at some statements and see if they're good or bad in terms of having an enumeration type. So there's nothing wrong with having an enumerator called grades. There's nothing wrong with having an enum called places, okay? But you have to do everything the way syntactically they work. You can't put any single quotes, meaning these chars in this case, around any values. That's illegal. You also can't start with any numbers. That's illegal, all right? So you could have the same values, so enum grades, but it's A, B, C, D, F, nothing around them. And first, second, third, fourth, that would work as well, okay? Now, the next one is consider the following statement. So you got a math student, and then you got a computer student. So John, Bill, Cindy, Lisa, and Ron are math students. Nothing wrong with that. And then enum for the computer students is, or computer student is Susan, Kathy, John, and William. That's technically illegal because this is in the same block, meaning the same block of code, because we don't see anything around it. And John can't be in both. And that's one of the things with enums. You have, it's very, you have to be careful with your code, with what you're doing, okay? You would never put code statements like this back to back. And really, enums aren't extremely widely used anyway, but they are in the business world for what I talked about. Employee, you would have. What would you have for an employee? Employee ID, F name, MI, L name, city, state, cell phone, emergency contact, zip code or postal code, you know, things like that. And then all of them could be different data types. And you're going to see how to do that with my programming example that I'm going to, well, the first one I'm going to give you in a couple days, meaning this same week that you're going to be hearing this video. All right. Okay. And now, so they have another one. This one they're calling enum for sports. So basketball, football, hockey, baseball, soccer, and volleyball. So here, again, basketball would be 0 based on the normal logic you've learned about in this class. And then 1, 2, 3, 4, and 5. So there's a total of 6 values, okay? And they range from 0 through 5. And then you can have variables, and this you're going to be dealing with in the first programming exercise you're doing in chapter 7 and 7-1. You'd have a variable based on an enum. So you can have sports. You see how here sports, that's the name of the enum. So in your program, you can type out sports space popular sport, comma my sport, or just sports space popular sport semicolon, and then sports space my sport semicolon, right? Just like if you're doing int, you can have 2 or 3 or 4 integer variables on the same line after you put the int, or if it's double, or if it's string, or if it's char, You can go from left to right or just enter, enter, enter. But this is how you then declare a variable. So this is the enum that can only have these 6 values ranging from 0 through 5, okay? And yeah, sure, you can call one popular sport. Like out of those 6, what's your most popular sport? You can assign popular sport to hockey or football or baseball or basketball or soccer or whatever, and you can have another one for my sport, all right? So that's similar to what you can do and will do. So the values can be stored in enumeration data types similar to popular sport equals football, stores football into popular sport. Okay, go back again. So in this case, right, so football, so here, sports is the enum, and we're declaring a variable of popular sport, which now inherits, because it is the enum with these 6 values. So in your popular sport, you can assign a value to it like football, but you can only assign one that's in the pool of values, okay? All right. Now, you cannot do arithmetic operations on enumeration types. So you can't say, again, my sport, you saw that was also declared. I won't go back now, but you know it's declared as a variable of sports. So you can't say my sport equals popular sport plus 2. You can't say popular sport equals football plus soccer. You can't say popular sport equals popular sport times 2. Can't do it. Can't do it. You can't do popular sport plus plus. You know, you can't go from 1 and then increment up that way. You can't do popular sport minus minus. You can't decrement either. You can, though, use, remember I said you can use a for loop. And in a for loop, obviously, usually we have something to increment whatever the variable is. So if we wanted to increase the variables, we're not basing it on these popular sports, like football or soccer. We're basing it on the integer values, the static cast, which we've done in this class off and on, not a whole lot, but a little bit. But so static cast means you take a value and you assign it to the numeric version. So static cast of sports was done with that, with those 6 values, and then popular sport plus 1. So if football is your popular sport, and if football is the second sport out of those 6, that means it has the number 1, okay, the index 1. Then you can say popular sport plus 1, which would be football plus 1. So that would be then the third one out of those 6 sports. And I think the third one was hockey. So then you would be assigning hockey then to popular sport, but only with a static cast. Okay, so you don't do it with the value or the what we call the enumerator. You do it with the int, because all of these values have indexes, and the indexes in the computer world, you know, everything is a 0, and it goes it goes up from there, you know, sequentially by 1 each time. So you can only go ahead and do arithmetic operators if you're using the cast operator. Okay, all right. So an enumeration type is an ordered set of values. Football is less than or equal soccer is true. This is only going to be based upon the values that we have in that particular enum, which we called sports. Well, I should say they called sports, okay? If you remember, the sports were, I think, basketball again, then football, hockey, and I'm not sure after that, but the games were baseball and soccer and volleyball. I'm pretty sure volleyball was last. But football less than equals soccer just means then if football's number is lower than soccer's number. And again, remember, think of these as the index. So I know football is the second one there. So 0 was basketball, so 1 is football. Soccer was either a 2, a 3, a 4, or a 5. So either way, football number 1 is less than or equal to soccer's number 3, 4, or 5. So it's true. Hockey, well, basketball was the first, so therefore it's 0. So hockey, I think it's the third, which is 2. But either way, hockey would have a higher index. That's all it means, remember. So hockey greater than basketball doesn't mean it's the most popular. You know, I'm Canadian. But anyway, hockey greater basketball is true. All right. Now, baseball less than football is false. But I don't have the list here. But you remember we saw it a few slides ago. I'm going to say it was basketball, football, hockey, and then whatever. Okay. So baseball was in the whatever. So that means it's a higher number because the indexes go up, right? Okay. Now, an enum is an integral data type, right? So that means it's a integral, meaning it's integer, and it can be used in loops. So how would we do a loop? Well, again, we're showing it right here. So for my sport equals basketball. Remember, my sport was part of that. The sports were 6 sports, right? And let me go back, and I'll just remember this is number 12. Let me go back. Previous, and then I can remember 12. Okay, so basketball is 0, then football is 1, 2 for hockey. So baseball is 3, soccer 4, volleyball 5. So B, F, H, and then B, S. I probably won't remember it all. But anyway, so that's what they are, all right? So then next, and next. Okay, so now if we're going through that iteration, there were 6 values, okay? So for my sport equals basketball, remember a for loop has 2 required elements that are followed by a semicolon, and then the third element doesn't have anything following it other than closing the for loop off, okay? And there's no semicolon afterwards. So for my sport is basketball, that means 0, and then until my sport is less than or equal to soccer. So, okay, so I think I said volleyball was the last one. So soccer might be the second last. So that means we'd have 0, 1, 2, 3, and 4 for soccer. Okay, because soccer would be 4, I believe. I think it was baseball, then soccer, then volleyball. So then my sport equals static cast. Remember, if we're going to try to increment through them, we have to turn it into static cast on the index values. So again, sports is the enum. My sport, which in this case we're saying is basketball. Basketball is 0. So 0, then the next one would be football. The next one would be hockey. I think the next one baseball. And then I think the next one soccer. So until we hit soccer. So that's going to, it's going to go through 5 times, right? 5 iterations, right? Okay. Now, an enumeration type cannot be input or output directly, but you can input and output directly. Right. So how do you do things directly? This is where, again, we go back to what we've been using in this class for the past, really for the past month plus now. We were using if statements, switch structures, the for loops, the while loops, and now functions, right? So now we're also adding enums. So in this case, they're saying enum courses. So we've got algebra, basic, Python, and you might say, why are they all in caps? Normally, enums are done in caps for the same reason constants are done in caps, because technically you are creating these values. They are constants. You're naming them right here, but also because it's above int main in the area where we declare our constants, and enums are above int main. So do you have to in this class? Yes, you have to do everything I do, or the book tells you to do. So when I demonstrate my programming example for the first one for chapter 7 in a couple days, I'll most likely use enums with capital letters. All right. But anyway, this one is 1, 2, 3, 4, 5, 6, 7. There's 8 things. All right. There's algebra, basic, Python, CPP, which is C++, philosophy, analysis, chemistry, and history. All right. All right. So then they're doing a switch. Oh, sorry. Courses registered. Remember, here's courses. Right. So in courses, we have 1, 2, 3, 4. We have 8 values. We're then declaring a variable on courses, and we're naming it registered. So registered now can use any of these 8 values. Okay. And how are we going to determine which one was selected? See here, it can't be input output directly, but here's how it's done indirectly. So it looks like we have 2 variables, ch1 and ch2. You know, when it's ch, it's normally char, right, for character. So we have a char1 and a char2. All right. So for char1, they have obviously used it for the case. So in the case of A, that means this would be char1. This would be char1. There's no other A's. So these would be the 2 for A, algebra or analysis. So the ch1 is the A. Okay. Now, so the switch is for that. So they're A. But then we are trying to compare, well, what's the second value? So if ch2 equal, and this equal, that's not a 1, that's a L. Okay, this thing I'm sort of hovering on, that's a L. All right, a small L. And then it's saying registered is algebra, because it's A and it's L. So AL up here goes for algebra. It doesn't go for basic, doesn't go for Python, doesn't go for C++, doesn't go for philosophy, doesn't go for analysis. The A does, but not the N. So it's the else for N, registered equals analysis. Okay. Now you might say, well, but professor, where is it telling us? How is it figuring out that a small a is now a big A? Well, obviously, you know that they're only showing us little bits of the code here, right? But we would have had, or they would have had a 2 upper if they're doing it this way, or a 2 under, 2 under, 2 lower. So in this case here, anything that's showing up as A would imply that we probably made the statement that they were taking the string values and lowering them, and then we're just putting it all, again, where that's they are putting it all in uppercase. Okay, so that would be an example for case with A. If they had a case B, it would then be looking. So here's a B, again, it would imply the first character. So char1, if that was a B, this would be here now case B. So basic, algebra, no. Yeah, B for basic, yes. Python, no. C++, no. Philosophy, no. Analysis, no. Chemistry. So there'd only be one, and it would then not need an else. It would just then be CH. Well, you wouldn't need it. It's just with case, B, you would then just put the value for the basic. Okay. And of course, remember, you always have to have a break. Otherwise, it's going to go into every further, any next case that you have. Okay. Oops. Let's see. Okay. So enumeration types can be passed as parameters to functions either by value or by reference. Remember, by value is just getting a copy of a value. A reference gives the memory location in addition to the value. So references are always dangerous, but we can do it. So enumeration types can be passed as parameters to functions. Remember parameters, functions, we had a function prototype, we have the call to the function, and then we have the definition. So if we're wanting to pass something, so from int main, we would be passing the parameter, which we then in this case probably got from the enum, to then pass that value to the function. Okay, and then a function can return a value of the enum type. So if we have the enum for standing, let's pretend this one is standing. So then if we're passing that value, when it gets to standing, it would have to either return freshman, sophomore, junior, or senior. Okay, all right. Now, can declare, so when defining the enum, you can also, so in this case, they're saying, all right, so we have an enum called grades. Remember, we saw this one earlier, A, B, C, D, F. But then they're already, so instead we could have done enum grades, A, B, C, D, F, semicolon, and then put an assignment statement to allow grades to be equal to, or course grade to be equal to grades. But you can also do it this way. That's what they're saying here. You can declare variables of an enum when you define it. So enum grades, the values, and then the variable course grade means it also has these 5 grades. Okay. Whoops. All right. Anonymous type values, I think I mentioned at the beginning, the first slide, it just means that we have the values, we have the enum keyword, all right, but we didn't name them. So in this case, what we're doing is we're going to have a variable. We already have it actually called my sport. But in this case, they're pretending we didn't have the first word. Remember, the enum was called sports. All right. So it could also have been done just enum, the values, and then put that in a different variable. Doesn't, to me, make a lot of sense to do that since you already had a variable sports. Okay. And then if you want to use those in another way, then yes, you would declare a variable on sports. But here they're now taking away the variable and just using an anonymous reference, meaning just taking these values and then assigning them to my sport though. Okay. So, and drawbacks, in my mind, there's a ton of drawbacks, but so let's see what they say. Cannot pass or return an anonymous type to or from a function. So meaning anytime, remember, with functions, you have to have a prototype. The prototype defines the function. You have to have the definition, which tells the same thing as the prototype, including the arguments. And those arguments are key because you need to be passing and verifying and then returning the values to the calling procedure. So an anonymous type, you can't do that with. So here, enum, and then they're giving us some languages, all right? And then they're assigning it to languages. Then they got the same thing, enum, same English, French, Spanish, German, Russian, foreign languages. So in this case, they're saying this statement, not these, but this. Languages equals foreign languages is illegal because languages, this gets back to that first statement that I had mentioned where it didn't really make a whole lot of sense. So you've got languages equals foreign languages. Well, you already have declared it that they're the same. So you wouldn't be saying languages equals foreign languages. You would use foreign languages or languages in a different capacity. You don't reference them against each other because they're already there as two independent variables. Okay. Best practice, to avoid confusion, define an enum type first, then declare the variable. Meaning, again, put the value over here. Enum languages, as an example, English, French, Spanish, German, Russian. Then you could have foreign languages to equal languages. You could do it that way. All right? All right. So the type definition statement, or type def, used to create synonyms or aliases to a data type. The syntax of the type def statement, you got to be careful with type defs because there literally is no comma into play here, because what you're doing is you're taking an existing type def. In this case, we're saying type def existing type name, and then we're just going to be giving it a new type name, which you commonly call an alias. Okay. So if when we had type def for, let's say, colors, and then we change it new colors or whatever, okay, you can do it that way. But type def does not create any new data types. It only creates an alias to an existing data type. So you're only using it with what you already have. Okay. All right. And the type def statement is used to create synonyms or aliases. That's what I just said. Type def does not create any new data types. It only creates the alias to an existing data type. All right, so namespaces. Now, namespaces, you know more or less this stuff here, but this won't be on any of your exams, obviously. But ANSI is your American National Standards Institute. It doesn't really matter that yet what the acronyms are. All the recent compilers are compatible with ANSI and ISO standards and standard C++. No problem. So there's nothing here. All right. But now, so here is they're going to start talking and showing us just a little bit on namespaces. All right. So global identifiers in a header file used in a program become global in the program. In other words, just like when we have a namespace, and if it's IOStream, if it's IOmanip, if it's anything that we're dealing with in the program that we're creating, they're built into the C++ libraries, or we're taking them in. There's a lot of third-party vendors these days, and the third-party vendors have a lot of C++ work that they are using to try to get part of the market of programmers that are using C++. And all of their identifiers will begin with an underscore, okay? So they're suggesting if we create a namespace, and again, there's going to be one program in programming exercises 1 through 6, or 1 through 5, sorry, remember there's no 6 for this chapter. You're going to be creating a namespace, and do not do any with an underscore, and that's just so that if we're using third-party libraries, they always begin with an underscore. Okay, that's all that means. Okay, so here would be a general syntax of the namespace standard, of the statement namespace. So you have a namespace, you have a name, and whatever members are. What are members? Well, the members are the variables, the named constants, the functions, or another namespace. So if you want to have a namespace that you want to use, even if it's not in your program, as long as you're referring to it via, you have the authority or you have the rights to pull that namespace up, then you can do it. All right. Otherwise, you'd have it within your own program, but you'd be referring to two different namespaces, and you can do it that way. Okay, so here is an example, namespace global type, right? Namespace global type. So it's got a constant an integer, constant, a double, an int for count, and a void for print results. Now, if you were going to refer to any of these values outside of this namespace, meaning once we enter after this closing right curly brace, then if we were to refer to n, which is this integer, we'd have to do that pound, colon, colon. Remember the colon, colon is like what I keep talking about when we're using namespace std. But if you didn't use the namespace std, remember before you could use coot or cin or end l, you'd have to do colon, colon, and then those keywords. All right. So in this case, all we have to type is after the closing curly using namespace global type semicolon, and then we could quote unquote see those variable values and this void. Remember, a void is a function that's not returning a value, but it's still doing something. Obviously, it's going to be printing a result. So if you want to use these values after the closing curly, you would type using namespace, just like std, but in this case, global type semicolon. Okay? All right. And a namespace member has scope local to the namespace. That's what we were just talking about. And it can be accessed outside the namespace, which is also what we were just talking about. Yeah, you can do it with the colon, colon, or just use the using namespace name, and then semicolon. All right? You can do it that way. All right, so example with the namespace. After the using statement, it is not necessary to put the namespace name colon, colon before the member, right? Just means exactly what I said a couple minutes ago about using your coot and your C inputs and your end L's. If you don't have namespace standard, then you have to type them out with that colon, colon, and then the values, okay? All right, and then closing this chapter out is more stuff on strings. So to use a data type string, a program must include the header file string, right? We went through that several chapters ago. A string is a sequence of 0 or more characters. We know that the first character is in position 0, the second is in 1, etc. We know that binary operator plus performs the string concatenation. In other words, if you have two strings, string F name and string L name, and for string F name we have John, for string L name we have Maloney, then we could do F name plus L name and assign that to maybe full name. Or so we could have another string called full name equals John plus, and then we have to do a double, the quote marks with a space, then the closing quote marks, then another plus, and then L name, and that would then throw it all together. But you know that, okay? And then the array subscript operator allows access to the individual characters in a string, meaning again the 0, the 1, the 2, the 3, if we're going to be doing some manipulation on those string values. All right. So data type string has a data type string, the size type, and a named constant string n position, which is the number position, the numeric position, defined as follows. So unsigned integers and maximum value of the string size is this value right here, all right? And again, you don't need the string colon, colon. This again is, remember, it's a namespace, you're using it. So, and they're referring to it from outside your namespace, okay? All right. So here, again, we're not really going to do that much, but there is one of the programming exercises that will be doing some stuff with string manipulation. Here we have a string called string 1, it's warm. Here we have a string called string 2, it's cold. And then after the following statement executes, the value of string 1 is cold. There's just a built-in, so string 1 dot swap, because it's a string and we're using the string library, then we can use the dot swap. Remember, dot is the notation you can use where you type things in and the values pop up. So string 1 dot swap means I want to swap string 1 with something else. And as long as you do have a variable called string 2, then the swap statement here would then flip it so that cold was string 1 and warm was string 2. Okay? All right. So, enumeration type, set of ordered values. Reserved word enum creates an enumeration type. No arithmetic operations are allowed on the enumeration type, but you can do it indirectly with the static cast, okay? Relational operators can be used with the enum type, and enum type values cannot be input or output directly, and we can use where we can be passed as parameters to functions by value or by reference. Anonymous type of variables values are specified without any type name. Not a good idea. Reserved word type def creates synonyms or aliases to previously defined data types only. Remember, again, you need to have a type name already in with the enum. Okay. The namespace mechanism is a feature that you don't need to worry about the ANSI ISO standards, but namespace mechanism is in the C++ compiler and the libraries. A namespace member is usually a named constant, a variable, a function, or it could be another namespace. And the scope of a namespace member is local to that particular namespace. Using statement simplifies access to the namespace members. A string is a sequence of 0 or more characters. Strings in C++, you know, are enclosed within the double quotes. First character is always 0, okay? And the open and left bracket and right bracket is the array subscript operator, and we're going to be getting more into this in chapter 8. All right, so have a great day. I shall be coming back in class with an example in the next class, but tomorrow you'll be reviewing this with me in class. Have a great day.